Alright, welcome to the first video on factorization for grade 10, and this is all the types of factorization that you're going to do all throughout grade 9, grade 10, and then all the way up to matric. So please, it will really help you a lot if you just get to know factorization. You are how you can easily recognize how to factorize an expression and what type of factorization it is. All right, so we're going to take it step by step. I have to make a few videos, and we're going to make one on each of these subheadings underneath factorization, just because of otherwise it will take so long, and I really want to cover everything perfectly on all types of factorization and all the types of sums that you can get. All right, so the first one is, and that's what you always start off with, is can I take out a highest common factor? So that would be your first start. Can I take out a highest common factor? All right, then if you have taken out a highest common factor or it's not a highest common factor, you are going to look whether you have 2 terms or 3 terms. 2 terms, it can be a difference of 2 perfect squares, or in grade 10, we are now teaching you the sum or difference of 2 cubes. So we'll get to those in the next video. Then if it's 3 terms, it could be, most likely is a trinomial. So you get, I always call it the Chacha trinomial and just a normal straightforward trinomial, grade 9 trinomial. So we'll get to those as well in the next or the third video. And then the even set of terms. If it's an even set of terms, always remember of the grouping of terms that you can also do. All right, after grouping of terms, you're going to look for a common bracket, and then it becomes the highest common factor. It links up with that one again. All right, so for this video, we're just going to look at the highest common factor, and we're going to look at a few sums. Now, you have been taught this in grade 9, and I hope that I'm not going too fast. But maybe with the first 2, I'll just go a little bit slower, and from there onwards, I will go a little bit faster. All right, so when you look at A over here, you've got 15x squared plus 9x to the power 5. So you want to first look at what is the common number that you can easily divide with both of these, a 9 and a 15, so that you have a beautiful remainder. Okay, so a whole number as a remainder or an integer as a remainder. So you're going to ask, what can I divide with both? Okay, I can take out a 3. I can divide both of these with a perfect 3. 15 divided by 3 will give me 5. 9 divided by 3 will give me 3. Then if you look at the variables and the exponents, I've got x to the power 2 and x to the power 5. I'm going to take out the one with the lowest exponent. Okay, and then it's always the lowest exponent. Then in brackets, what is left? All right, so we're going to take that 3x squared and we're going to divide it with this term over here and then with the second term over there. So 15x squared divided by 3x squared, 15 divided by 3 is 5, and x squared divided by x squared falls away, so you've just got 5 left. Plus 9 divided by 3 is 3. X to the power 5 divided by x to the power 2 gives you x to the power of 3. Remember, when you divide, you keep your same base and you subtract the exponents. And that is your answer. Now, people, you can always go and test yourself by, if I had to distribute this back into the brackets, that I would get the first original. So you can always check yourself. 3x squared times 5 gives you 15x squared. Plus 3 times 3 is 9x to the power 5. And that's exactly what we started off with. So you factorized correctly. All right. So just again, the main point of factorization is to make many terms one term so that we can further simplify. So maybe I'm just going to quickly explain it here at the top. So if I've got 2 plus 6 divided by 2, you cannot go and divide those 2 2's out and say the answer is 6. That is most definitely incorrect, because 2 plus 6 is 8. 8 divided by 2 should give you 4. But if I can factorize the top, taking out a 2, what is left? 1 plus 6 divided by 2 is 3. divided by 2. Because I've made it one term, you are now more than welcome to go and cancel those out and say the answer is 4, which is correct. Okay, so please, that's why we do it. Obviously, we don't have just straightforward numbers that we can just say, well, 2 plus 6 divided by 2 gives you 4. We have variables, and that's why we do factorization, is to further simplify. All right, let's look at the next one. I've got a 24 and a 3, so I can take out a 3, a to the power 4, and a. If there's nothing, there's a 1. So you take out the one with the lowest exponent. And b, I've got a 6 and a 2, you take the one out with the lowest exponent. And now you're going to take each term and divide it with what you've taken out. So 24 divided by 3 gives you 8. A to the power 4 divided by a to the power 1 gives you a to the power 3. B to the power 6 divided by b to the power 2 gives you b to the power 4. You subtract the exponents. Minus 3 divided by 3 falls away, a divided by a falls away, b squared divided by b squared falls away. So now lots of you like to just say that's nothing left. It's not nothing. 3ab divided by 3ab squared divided by 3ab squared gives you 1. Okay, so please remember, anything divided by the same something gives you 1. All right, now we get the ones with the common factor, where the common factor is a bracket. Okay, so now I want to use my colors. If you can see, there is 2 terms over here. There's a term and there's a term. So remember, a term is separated by a plus or minus unless it is inside a bracket. So there's one term and another term. Then I'm going to take out, in this term over here, there's a common bracket of x plus y and x plus y. So I'm going to take out a common bracket, which is x plus y. Then, if you take this term here and you divide it away with x plus y, can you see that the 2 brackets are going to cancel out? I'm just going to do it properly like that. And then I'll just reverse it, just so that we don't scratch out our sums. So what is left? 2a. And then, if you take this term over here and you divide it away with x plus y, those 2 will cancel out and you're left with negative 3b. All right, but people, in your answer, lots of you just leave out the x plus y. You must write down the bracket that you've taken out like that. Okay, so I just want to erase this, that line over there. Okay, and that is your final answer. Now, with the 2 brackets, remember that x plus 2, now I've done the wrong thing, sorry. Let me just get that back over here. All right. Sorry. If you've got, these are your 2 terms. If you've got x plus 2 and 2 plus x, remember that 1 plus 2 is the same as saying 2 plus 1. So you're not going to change the sum or change the value of that sum by just swapping these 2 around. So there's no sign change needed. All you're going to do is swap it around. So then you've got 3x plus 2 minus ax plus 2. And now they're exactly the same. You can take out from the 2 terms, you can take out this common bracket over here and that common bracket over there. And once you take it out, if you divide this term away with x plus 2, those 2 will cancel out. Don't cancel that though, and that gives you 3. Minus, if you take this term and you divide it away, the x plus 2's will cancel out and you are left with a. Again, please, you cannot cancel that out. That's part of your answer. All right, and that is your final answer. X plus 2 times 3 minus a. All right, what if your HCF is more than 1 brackets bundled together? So you've got x minus 1 to the power 6 minus x minus 1 to the power of 4. So again, just remember, if that bundle, I always say I call it a bundle. If it was just x to the power 6 minus x to the power 4, you would have said, okay, I take out x to the power 4, and what is left? X squared minus 1. So I'm going to do that now. Instead of just the x, I'm going to write it as x minus 1. So I'm going to take out x minus 1, and the one with the highest common factor, the highest exponent is the 4. Then what is left? So if you take this term and you divide it away with x minus 1 to the power 4, you're going to be left with x minus 1 to the power 6 minus 4 is 2. Minus x minus 1 to the power 4 divided by x minus 1 to the power 4. Exactly the same thing divided with the same thing gives you 1. So because there's now these double brackets, we're going to clean up, everybody clean up. So when you can simplify inside the bracket, you have to. So we are left with that x minus 1 to the power 4. What is left? I'm going to do the quick way that I've explained in my previous video. X squared, a negative 1 times x is a negative x, times 2 is negative 2x, and negative 1 squared gives you a positive 1. And then that minus 1 still. Then I'm going to clean up further. What is left? X squared minus 2x, because the plus 1 minus 1 falls away. And that is your final answer over there. All right, I'm just going to do another one like this. So again, you've got a bracket and another bracket. And it's to the power 3 and it's to the power 2. So I can take out that common bracket. And am I going to take out the 2 or the 3? Yes, it's going to be the 2 because it's the one with the lower exponent or the lowest exponent. Now what is left? So if you divide away this term with what you've taken out, what is going to be left? So a 2 and how many a plus b's? So there's 3 minus 2 is 1. So it's 1a plus b. We're going to clean it up just now. Minus a plus b squared divided by a plus b squared is nothing, or it's 1. Sorry, not nothing. It's a plus b squared divided by a plus b squared. It's the same thing divided by the same thing gives you 1. And then we're just going to distribute. We're going to clean up our brackets over there. So it's a plus b squared and 2a plus 2b minus 1. And there's no like terms to add or subtract further. So that would be your final answer over there. Okay, I hope it makes sense. Just take some time to take it in. So instead of now, just because it's a bracket, just see it as a little bundle. It's an a plus b packet. And that's to the power 2. So if 3 packets minus 2 packets will give you 1 packet left with that 2 over there. Okay. I hope it makes sense. Then we're going to look at the sign change rule. And I just want to explain how you can do that. Because I think if you understand why you can do it, it will make better sense. Okay. So what we are in actual fact trying to do is we want to change the signs here because we want to change our terms. Okay, sorry, I just quickly had to pause there. So I'm just going to restart where I've left off. So basically what we want to do is we want to swap these two around and we want to change their signs. Why? Because we want to make it look like this previous bracket that was over there, which you'll see in the next slide that we're going to deal with. So I just want to show you that you can do a sign change. Okay, so what we're going to do is let's first see if you had to work this out and you say 2 plus 3 minus 1. 3 minus 1 is 2 and 2 plus 2. So the answer we know that is correct is 4. Okay, that's what we want to get to. Then, if I do this, I want to see if I do a sign change, if I still get 4, if I'm allowed to do that. So I'm going to change this positive into a negative. But when I do that, there's a rule that goes with it. So they say I can change it as long as every other sign it rolls out. I always say it rolls out into the next bracket. As long as the positive 3 then becomes a negative 3 and the negative 1 becomes a positive 1. So let's see if we're allowed to do that. Am I allowed to just take that positive, change it into a negative? As long as I do that, then I have to change the positive to a negative and the negative to a positive. Let's see if I get the same answer. So it's 2 minus negative 3 plus 1 gives you negative 2. 2 plus 2 is 4. So you are allowed to do that. Okay, let's look at the next slide then. So this is what I was explaining. You want to take a highest common bracket. But now, at first glance, it might look that they're the same. But if you look closely, here the 3x is standing first, here the 3x is standing second. And not only that, this 3x is a positive, and this 3x at the back here is a negative. This negative 2y is a negative, and this 2y at the back is a positive. So I'm going to implement my sign change. So I'm going to change that positive into a negative. When I do that, this 2 is going to also have to become from a positive to a negative, and this negative 3 must become a positive 3. Okay, so let's do all of that. 2a, 3x minus 2y. I'm changing my sign. 5b. Then the positive 2y must become a negative 2y, and the negative 3x must become a positive 3x. And now you say to me, all right, but they've got the same signs, but they're not in the same order. So then you are just going to take those two terms and swap it around. You are allowed to do that because 3x minus 2y is the same as saying negative 2y plus 3x. So we're just going to swap them around. Voila, voila. Then we've got exactly the same bracket. And then we can take out that common bracket like we've seen in our previous slides. And then what is left? If you divide this term away with this, you'll be left with 2a minus 5b. Again, if you take this term and you divide that bracket away, then you're left with negative 5b. And there's your answer. All right. Normally these sums are, oh, sorry, there goes my school bell. Normally these sums are for two marks for changing the sign, changing the order, and then a third mark for taking out the highest common factor and seeing what is left. All right, I'm going to pause the video here and I'll just continue just now because I'm going to teach. All right, thanks for watching so far, and then we're going to do a few more of these in the next slide. All right, and then if we move on to the next slide, if you look, you've got m minus 3n, and at first glance the brackets look the same, but if you look closely, it's a negative 3n, and here's a positive 3n, over here is a positive m, and at the second bracket is a negative m. So I'll need to change the sign in the middle to a positive, and then the 3n will become a negative 3n, and the negative m will become a positive m. All right, so let's do that. So I've got 7x m minus 3n plus 4y, and then I'm just going to swap them around as well so that the negative m becomes a positive m and the positive 3n becomes a negative 3n. And by doing that, I can take out a common bracket, and what is left is the 7x plus 4y, and then you are done. Then for the next one, if you've got 3 brackets, no stress. I can see that it's a minus 3b, then it's positive 3b, where this one was a negative, it's now positive 3b, and the positive a is now negative a, and the same over here. So I'm going to change this sign to a positive, which will make the positive 3b a negative, and the negative a positive. As well as here, I'm going to change that positive to a negative, which will make the positive 3b a negative and the negative a positive. Okay, so I'm going to start a minus 3b. So the negative becomes a positive c. And then I'm going to change the negative a. I'm going to swap it around as well. So the negative a becomes a positive a. And the positive 3b becomes a negative 3b. Oh, voila, voila. Look at those brackets being the same. Then the positive becomes a negative d. Swapping around as well. I'm going to first work with the negative a becomes a positive a. And the positive 3b becomes a negative 3b. And now you've got a common bracket. A minus 3b, a minus 3b, a minus 3b. All right, so I always do it like, I highlight them like that in a hearty. And then if you're going to take out, the a minus 3b. Okay, so remember this term. If you divide it with exactly that, there's a 1 left. Then you take the positive cb and divide away the bracket, then you're left with a positive c. And the last term over here, if you take away the bracket of a minus 3b, or you divide away with it, you're left with negative d. And there's your answer. I hope this helped. I just want to quickly, I thought I was done. Let me quickly, just very, very important, NB. We never ever start off with a negative. So always start with a positive note so that we are happy. So never ever do we start off with a negative with factorization. So just always remember, when you take out a negative, it will change then all the signs that we have there. The negative AB will become a positive AB, and the positive AC will become a negative AC. And you can always test yourself, if you had to distribute it back, does it give you that original expression that was given? Negative AB plus AC. Same over here. If I take out a negative, I can take out a negative. There's a common 6 that I can also take out. I've got 1A, so I can only take out 1A. There's a B squared and a B, but the one with the lowest exponent. Then what is left? So if I'm going to divide this term, the first term, with what I've taken out, I'll be left with a negative times a negative is a positive. 18 divided by 6 is 3. Then a squared divided by a is a, and the b and the b will cancel out. Then the next term, a positive 24ab squared, that you're going to divide away with what you've taken out. So positive divided by negative is a negative. 24 divided by 6 gives you 4. A divided by a will fall away. B squared divided by b is a b. Okay, then the very last term, negative 6ab divided by negative 6ab. A negative times a negative is a positive, and 6ab divided by 6ab is 1. Okay, so please remember that if you divide with exactly what is there, it stays a 1. All right, and then you just always ask, can you clean up? Can you add or subtract any of these terms here? No, you can't, because they're not like terms. All right, and that is it for factorization of the highest common factor. This is all the types of factorization that you would need to know all the way up to matric. So please make sure that you understand this part of factorization. I will make after this part 2 the video of the difference of 2 perfect squares and the sum and difference of 2 cubes, which is also all the way for up to matric. All right, I hope you have a wonderful day, and I will see you next time. Thanks, bye.